Hi, I'm Alistair, and this is the first in a series of videos in which I'd like to teach you how to use some software called Node.JS to create an escape room control system. So this is software that you can run on your PC or on a Raspberry Pi, and it's going to enable you to connect all of your individual puzzle controllers together along with your sound system, lighting system. It can interface with social media and CCTV cameras. It's really powerful software, and best of all, it's free and open source. Now it runs in your browser, and it looks a little bit like this. In the corner here you can see a window, so it's a graphical flow-based editor, and you can sort of drag these nodes in to connect different devices together. And then you can set up flows that determine how they're going to interact with each other. Now, in this video, I'm just going to start off by explaining how to set up Node.JS to start with, and how to set up some game events. So things that happen when the game starts up, or at certain events after a certain duration, or when a trigger happens or something like that. So for example, that could be the timer system in a room. So if I click the start node here, I'll start a flow going, and I've got two examples of how you could use that in the room. So I've got Node.JS running a game timer in the background. That's being used to update this video display at the top, but it's also being used to send a message to the clock prop here, which is a prop I've used in the past. That's updating the position of some stepper motors. Now from the games master point of view, I can stop that flow again by clicking the stop button. I can reset it, and the timers reset back to where they started from. So that's what we're going to cover in this video. In later videos, I'm then going to explain more about how you can interface with Arduinos and Raspberry Pis and DMX and MIDI controlled and lots of good stuff. It's really amazing software. I'm looking forward to showing it to you. So we start by going to the website https://nodejs.org, and then coming across to the documentation tab here, and then on getting started. Now, as you can see, you can run it on lots of different examples, on the web, on different devices as well. We're going to run it locally, so we'll click Run Locally. Then I'm on Windows, so I'm going to come to this little link here. If you're using Windows, click here. And there's some very simple steps. The first step here just says Step 1, install Node.js. So we'll go to the Node.js homepage. And from here, we'll just go to the current version of Node.js and download that. Save that file there. And then we'll wait a second. And then once that's downloaded, if I just click my downloads bar, open that and click OK to run the executable. And then here we go. So welcome to the wizard. Next, accept the terms. Now I'm just going to basically choose all of the default options here. So I'm just going to step through all the different options. Next, I'm not going to make my own module, so next, and install that. Now just wait. It doesn't actually take very long, so we'll just wait for that to install there. And there we go. Okay, completed Node.js wizard. Okay, so with that done, we no longer need this window open, so we'll just close that. Go back to Node.JS, so step 2. So now we install Node.JS using the Node package manager. So we'll load a command line, command prompt first, which I've got here. And if I just shrink that up a bit, so let's go back to the root. And then I'm just going to type this command, so npm install -g, and then --unsafe -perm, and then node.red. So hit enter, and that's now going to, so npm is the node package manager, which is what you can use for adding additional modules to your Node.js install. So this is going to add the node.red sort of module to Node.js. There we go. So it's added 294 packages in 15.9 seconds. Okay, lovely. So move that out of the way, and we're ready to step 3. So once installed, you're ready to run Node.JS. So let's see what that says. Once installed, the simple way to run Node.JS is to enter Node.JS commands in a command prompt. So back to the command prompt, and we simply type Node.JS. enter. So here we've got a Node.RED running, and we can leave this command prompt window open if we want. It will actually output some information there, or we just got a little warning. Now, because we're going to connect to devices over our network, we just need to allow it through the firewall. That's what that message there was. You can read this message here. It says about setting credentials, which you probably should do long term, but I'll let you read the extra instructions which are listed on the website here, because there's a bit more information about how to run it automatically on startup and things like that as well. But it's now running in the background, so we can get on and I can actually show you how it works just through running those steps like that. So we're going to create our first flow. So we'll click that. And our first flow, so it's going to be by going to a local website. So there's local host on port 1880. If we click that link, it will load in the browser, and here we've got our first flow. So let me just talk you through the basic visual here. Here in the main bit of the window, we have our flow editor. And this is going to be our sort of graphical panel where we're going to draw the connections between different devices. And you see we've got a single flow at the moment, flow 1, and you can add extra flows here by clicking the plus buttons. These are a bit like worksheets in an Excel workbook or something like that. You can have a number of tabs, and each one will contain a series of steps related to something in the puzzle. On the left-hand side here, this is what's called the palette. So this contains the different nodes that we can drag into that flow editor window, which are going to represent data coming in or out, or steps that happen on the way. So we've got an inject node. That's going to be the start of a flow. That's going to inject some data at the start that something's going to happen to. So we could drag that there, for example. And then maybe we're going to have a function that does something to that data. And then we might want to debug some output at the end. So we've got 3 steps, and we can connect them together simply by clicking and dragging lines between them like that. And this is now a flow, so it runs from left to right. And when you click on any of the nodes in a flow, you get this little information window on the right-hand tab here. You can also get some debug messages printed up there. So that's kind of how it works. Let's get rid of that, and let's start by creating some game flow elements. So we'll rename our flow 1 tab. We'll click there, and we'll call it game flow instead. We can add a little description here as well. So we'll just say this contains elements related to the overall game flow, for example, timer, events, etc. So this is sort of global game objects. And we'll click done. We'll get the description there. And then what we can do is we can actually start adding some elements here. So we'll add an inject node to start with. So we'll drag that in from the palette. And then what we'll do is we'll add, so we can now edit that by double clicking it. And you can see the properties of that inject node. So we're going to inject this once after 0.1 seconds. So just after the program starts running, this is going to trigger this node to happen. Most of Node.RED things are event driven, but this is going to be an event that triggers at the start of the flow. So we're done. That's our setup node. And now we can see that little blue icon. That means it's been edited since last time it was added. Now let's add another inject node. We'll put this one here, and we'll double click, and this time we'll call this one loop. And once again, we'll run it once when the flow first starts, but then we'll also choose to repeat it every 1 second. You can set a different interval if you want, but to start with, I'll just choose every 1 second like that and click done. So you'll notice I've called them setup and loop. So these functions mirror the behaviors of the setup and loop functions in an Arduino code. For example, I've got one that runs at the beginning and one that runs continuously. And this is where we're going to be able to apply our game logic. So what do we want to run in the setup node? Well, we're going to want to run one-off events that happen when the flow first starts. In the loop node, we're going to want to poll devices that we want to update kind of several times, things like that. So let's add some more things to our flow. Let's add a change node, and we'll drag that up here, and then we'll connect setup to our change node like that. And what's our change node going to do? Well, if we double click that, what we can do is we can set the value of some global variables. Now, Node.RED uses the idea of contexts. So you see at the moment it's setting something called MSG. The message context relates to variables that can be accessed by all nodes that are connected together like this in a line. That's the message flow. So when you set a variable with an MSG context, that's something that can be accessed by all those nodes. The flow context, that relates to any node that's on this flow tab, so this worksheet. And the global context, that can be accessed by any node anywhere. So they're listed in increasing order of kind of how widespread they are. So for things like game state, we're going to want to use the global node. So let's create, what's our global variables? We want to have the game state. So what's the overall state of the game at the moment? And what that's going to be a, you can see several types of variables here. We're going to make it a string though. And we'll just, we'll initialize the game state as saying it's stopped, for example. There we go. So our global game state is going to be, we could make it a Boolean and say like, you know, is game running or not? But no, in this case, I think we'll have more options available to us as a string value because we can make pause or whatever. Let's add another change node. Again, it's going to be another global variable. And this time, rather than the game state, let's call it time remaining. Now, the time remaining at the start of the game, well, this is going to be a number. And what value we're going to count? Well, we're going to count the time in milliseconds is how time is normally set up in Node-RED and other things. So we're going to do 1,000 milliseconds multiplied by 60 seconds multiplied by 60 minutes. That's going to be, for a 60-minute game, how much time there'll be remaining at the start. And if you actually work out what that is, it's 360, 0000. So that's going to be our global time remaining that will set that variable at startup. So when the flow first starts, we're going to set that variable there. Okay, and we'll add another one here. And what we're going to do now is going to be another global variable. And this time we're going to have what the current time is, because we're going to work out how much time has elapsed by comparing the time to the last time we looked at the time. So we could make an expression that calculates it based on a system value, but we can do something else actually here. We're going to send something called message.payload. Now the payload is the value that's sort of passed along from each node to the next one in the string. If I go back and look in the setup node, the default value when we inserted that inject node, the payload was the timestamp at which that node was called anyway. That's the default value that the setup node passed through the message context into the next node. So we can set the global current time, the time when the flow was started, equal to the message payload that was sent in from the inject node at the start. So you can set variables equal to other variables, you can set them equal to constants. That's how you can kind of pass messages around. So let's done that. And that's our initial setup done. Now let's take a look at the loop node that we had here. So this was an inject node, remember, that's getting called every second while the Node-RED engine is running. Now with the setup we used a change node to set those global variables, but there's actually a couple of other ways you could do it, and for this one we're going to use a function node instead. So we'll drag the function node in here, connect it to the loop, so that's going to make it being called every second. And then if we double click to edit this, what you'll see here is that we actually get like a script editor window, and this is JavaScript. So like I say, this is Node.JS engine is what Node.RED is running on, and we can type some JavaScript in here. So we're going to type var current time is equal to msg.payload. So remember, we're sending the current time when the loop is called. The timestamp is being sent in the payload of the message throughout this flow. So we're going to retrieve that message payload and assign it to a variable called current time. We're also going to keep track of when the last time we received a node was, and we're going to get that from the global variable that we just assigned. So we'll get the time at which the last time this function was called. Although we set that time interval to say once every second, it might not be exactly every second it's called. So this is a more reliable way of doing it by comparing the timestamps. And we're going to get the time remaining on the counter. Again, that was another global variable that we set in the change node at setup. So we're going to get the current time remaining, or if we can't get it for any reason, we'll just assign a value 0. And we also want to know what the game state is. So we can get global.get, and then we'll write game state. So those are our global variables that we set in setup. They're all assigned there, and now we've assigned them so they're variables that we can access within this script, so we can actually write some logic based on them. So if the game state is playing, because we only want to reduce the timer while the game is actually in progress, so we'll write if game state is playing, and a few more lines there. We want to, so first of all we want to get the time remaining, we want to reduce that by the amount of time that's elapsed since the last time this node was called. So we do the current time minus the last tick time, that's the amount of time that's elapsed, and we'll subtract that from the time remaining. And then what we'll do, we will update the global variable again, so we'll set the new value of time remaining, the global variable to time remaining. So this global.set is exactly the same as where we used the change node in the setup function, but rather than using change node, we're writing a script to set the global variable. It doesn't make any difference, you get the same answer either way. Then what we want to do is we want to pass on the new time remaining. So having updated the time remaining, if the game is playing, we're going to pass that down the message flow. So we'll set msg.timeremaining is equal to time remaining. So that's setting a message context variable based on the newly calculated time remaining. We'll update the last tick time, so that next time this function is called, it does the correct sums because it knows when it was last called. And let's think, is that everything we need to do? Oh no, what we'll do, one more thing. We'll just, so this node status, this doesn't actually change the functionality at all, but it's a useful little way of displaying some data in the editor, so that when you have this data that's being passed through this flow of nodes, it will kind of give you a visual display of the data that's actually being passed through each stage, which is quite useful for debugging. So it's a little bit like doing a kind of a serial print line in an Arduino code. It'll actually let us display the values of any data. So we'll put a green dot and we'll display what the time remaining is underneath this node. So that's all our script there. Don't worry too much about if you didn't follow all of that, you will get used to it, but we'll just click done. So that has saved the changes to our function node there. So we've got our setup, which is setting some global variables. We've got our loop function, which is calling a function every second. So that's the basics of a game timer setup. What we now need to do is we'll insert something that is going to actually make our game start and stop. Oh, actually, no, first we'll click deploy. So deploy is a bit like saving changes. So every time you've made a change, you just deploy it. And you can see we've got our function. This is our node status there. So remember I said that it was going to update the value as a flow gets passed through. And you can see we've got our initial game time set up. Let's just, now, because the game state stopped at the moment, that variable's not going to be updating, because this only changes when the game state's playing, and at the moment we're initializing the game state to stopped. So the next thing we want to do is to be able to do some way of changing what the game state is. So let's put some new inject nodes down. So we've got one here, and we'll give this one a title. We'll call this one play, yeah, we'll just call it play, so that's going to start the game, and we'll do another one and we'll call it stop. Okay, like that. So we've got two new injects, and this is going to be used to change the game state. So we need a change node here. That's going to go into the play one. And then we'll copy that and paste it. Now we've got another change node here. So this top one is going to set the global dot game state to playing. Done. And the bottom one is going to set the global dot game state to stopped, like that. Okay, so we've got two inject nodes going to two change nodes. I'm just going to deploy that again, so that's saved my changes. And now if I click these buttons here, what they'll do is they will inject that message into the flow. You see it's successfully injected. And what you see now is that node status here has started counting down because the game state has changed from stopped to playing. If I click this one, we'll inject the stop message, and the change node here has changed the player state to stopped. So the counter stops counting down. Let's copy those two nodes and we'll paste them and do another one, because what we now need to do is the ability to reset the counter back to the beginning again. So we'll just create another inject, call it reset, and in this one, so you can probably work out what we need to do. What we need to do in this one is to change the time remaining back to, it's going to be a number, and it's going to be 360000. So that was the initial value that it was again at the beginning. So we've now got three buttons. We can play the game and the counter starts. We can stop the game and the counter stops. And then we can reset the game and the counter goes back to the beginning again. So we've got the basics of a game timer. Okay, so we've got our countdown timer, which is being displayed under a node here in the editor. And we've got three buttons, three actions, which we've got here, which is controlling the game timer. But what we really want is that value there to be displayed in the room and for these buttons to be on a sort of dashboard. So we need to create a more sort of visual interface. Now when we look down the palette of nodes here, by default we haven't actually got any UI nodes there. So what we need to do is we need to add some new elements to the palette. So we'll click here, go to Manage Palette, and if we click on the Install tab here, we can search for modules. You see there's 2,000 modules here. This is a bit like libraries for Arduino that add extra value to node red. And what we'll look for is the dashboard nodes. So this is one at the top. You can actually see that there's a whole range of different here. There's averages, charts, bar graphs, all sorts of things. But the one that we want is this node red dashboard here. So we'll click to install that. And it doesn't take too long to install. So we've got some new nodes added to our palette now. You can see a load of UI nodes. So let's close that window and then come back and look down our palette list. And now at the bottom, what we should find is all these light blue nodes here for different kinds of UI elements. So we've got some at the bottom that are kind of outputs. We've got text, gauges and charts, and even an audio here that we can use. We've also got some kind of inputs. So we've got buttons and sliders and form controls, things like that. Now for our timer, let's start off by just putting it on a simple text output. So we'll drag a text node in here, and then we'll connect it up to our time output there like that. And then if we double click our text node to edit it, now, so at the moment, by default, it's displaying the message payload. Now, I think though, if you recall, throughout this tab here, what we actually created was something called message.timeRemaining. That's the thing that we added to the message context and got passed along. So that's what we actually want to display in our text node instead. We'll put that there like that. So we'll do paste, lovely. And then do we want a label for our timer? If so, we could type time remaining just up here like that as well. Now, for this bit here, whereabouts on the dashboard is this going to be displayed? And Node-RED has this idea of groups and tabs. So to start with, we haven't got any groups assigned. So we're going to click the button here. And we're just going to add a new group, which is just going to be called default. So that's like a page basically on the dashboard. We're also going to add a new tab, which we're going to call home. So we'll just go with the defaults for now. I'll show you the effect of change those later. So we go add. So we've now got a group and a tab defined. So that's given our text node somewhere to get displayed, essentially. That's what it's going to do. So we'll now deploy again. We successfully deployed. Now, we haven't noticed any change on the editor yet. That's because the UI, the dashboard nodes, get pasted to a slightly different address. So we're on the flow editor at the moment. If we just take localhost 1880 still, so we're on the same port, but this time we're going to put a forward stroke and put UI, and this is where our dashboard gets published to. So all those dashboard nodes get here. We see we've got a home group and we've got our default with our time remaining counter. we come back to the editor like this, and we'll click the play button just to inject that play message. That's changed the game state. We can see the updates here happening, and over here we can also see that it's now getting updated in our browser window. Great. Okay, but if we stop the thing or reset it, sure enough, the timer is now stopped and reset. Okay, so that's the basics of the functionality worked out then. But at the moment we've got our three actions, our play, stop and reset, are being run from the editor. And what we really want to have is a button instead that could be on a dashboard to control them. So let's take a button node from the palette here and we'll drag it into our workflow. And what I'll do is I'll wire that into that change node. So whereas we previously had an inject node, we've now got a button node. And double clicking on that, again, we can see that we choose a group that it goes in. We'll use the home default group again, so the same one that the room timer is in at the moment. We'll just click done. And we'll take a, we'll just hang on, just make a bit more room on the flow. So you see it's so easy just to sort of drag things around. It's very nice and graphical. We'll bring another button in here and we'll wire this to the change node that the stop was doing, and a button here that goes to the reset node as well. And we'll just as we went into the button here, or let's give that a better name actually, so this can be play. This one here we'll call stop and done, and then this one here we'll label it as reset, so we actually know what the buttons are going to do. So there we go, and we'll click deploy and then go back and look at our UI tab again, and we see we've got three buttons now. Here we go, play, stop and reset. So now we don't have to go back to the editor tab each time to start the game running. We can actually do them here right on the page itself. Okay, so we've got this value at the moment, this funny value at the bottom here, which, like I said, is currently counting in milliseconds. Now, that's all very well for when you're doing game logic, but for a display that's going to appear in an escape room for players to see how much time is remaining, we're going to want to format that into something a bit more useful. So let's add a bit of space between our function node and our time remaining, and we're going to add a new function node into this flow. So I'll grab it here and we'll just redirect the flow via this new node. We'll get rid of that one, so delete to hit that one. And we'll just clarify, so we'll name this function node as to what it's doing. So this function node is going to update the time remaining, but it's still in milliseconds at that point. So this one we're going to format the time as hours, minutes and seconds, so that by the time it gets to the text node it actually looks a bit prettier. So again, this is a JavaScript function, so we'll declare a variable called t, and what we'll do is we'll start off with that time remaining variable which is being passed in the message context, and we'll divide it by 1,000, so that will give us the value in seconds, because it was in milliseconds to start with, divide by thousands to get in seconds. And then to get the hours of that, we'll take the math.floor functions, that's like rounding down, of whatever the time is divided by 3,600. So that's 60 by 60 by 10. We'll take the minutes by taking the rounding down of the modulo of that, divide by 60. And then we'll take the seconds function by taking the floor of the remainder, so t divided by 3,600. So these are like standard sort of formula. If you've worked with Unix timestamps and things before, that's kind of like a fairly standard way of retrieving hours, minutes and seconds from a timestamp. So don't worry too much about that particularly. And then we'll now what we'll do is create a text string, so we'll put it in quotation marks, of the formatted time, and we're also going to want to pad the time with leading zeros. So I've put a 0 there, and then we'll add whatever the hour value is onto it, and then we'll just what's called slice. So we'll take the first two digits having appended a 0 on, or sorry, the last two digits having appended a 0 on the front. So basically, if hour was a single digit value, it will put a 0 in front of it and then take two values. Same for the minute, and same for the second. So if we put a 0 on the front like this, just put that in brackets, and then we take the value itself, which could either be a 1-digit or a 2-digit number, and then we'll just slice off whichever excess digits we've got. So what we'll get is a 2-digit string that has a leading 0 if necessary. That's what that bit does there. So we'll just put a little comment in there. So again, just as in Arduino code, obviously you can put a comment with 2 oblique strokes at the beginning of a line like that. So we'll copy that, because now our time remaining, we don't want to display time remaining anymore. That's still in milliseconds. What we want to do is display formatted time remaining, which is the string we've just generated. So we'll deploy that, to the UI tab, and ooh, hang on, that doesn't quite look right. What have I done there? Let's go back in here again. Oh, I've missed off the colon separator between the minutes and the seconds. Let's put that in there. There we go. Click done, deploy, and check that again. There we go, that's a bit better. So now we've got our buttons and we've got our time remaining. Now, of course, the problem is now we've got our time remaining is what we want to display to the players as well. The buttons we want the games master to have access to. So what we're going to also do is to create an output that shows, as well as the time remaining to the dashboard for the games master, we're going to want to create a new dashboard which will be for the display that's going to be used in the room for the players. So we can click Add Tab here, and we can just edit that, and we'll call this one Room, for example. So this is what's going to be displayed on a second monitor that's going to be in the room itself. And we're going to add a group into that tab. So to start with, we've only got one group in each tab, but that's fine, you can add more later. We'll call this Timer. So there we go. So we've now got 2 groups, and each one's got a tab. If we update that and go over to our dashboard, oh, hang on, I haven't actually put anything in the new tab yet, so you won't be able to see it. If we've got our formatted time, let's create another output from that we can put in our new tab. So we'll take another text output up here, and we'll drag into there, and we'll assign this to our new node here. And remember, we don't want to display the payload, we want to display formatted time remaining, just as we did with our other text node. And this time, let's not have a label with it. So our in-room display is just going to say, so this is our room display, and this is our dashboard display. So our dashboard games master can start and stop the time, and then the room display has the time itself but no buttons, so it's just the timer. Now obviously at the moment this doesn't look very excitingly styled. We've just got a text node that's going there at the moment. So the next thing we might want to do is to add something a bit more exciting. So a template node here. This lets us create a dashboard element just based on free text, HTML and CSS. So let's try directing that flow into a template node instead, and I'll show you how to use one of these. So it comes with a little bit of HTML already there, this bit at the bottom there, but we're not going to make use of that. So I'm just going to erase whatever was there to start with. And instead I'm going to start adding the HTML template that's going to display a slightly more exciting timer to go in the room itself. So we'll start with some div elements, and we'll just put another div in there, so we've got some sort of containers to give it a bit of structure. And this is the main important fact, so I'm just going to put msg.formatted time remaining. So just as with our text node before, if I were to publish this exactly as it is now, oops, that's a bit of a typo, this would basically be acting exactly the same as just that text node was on its own. We've got a div, and that div is displaying a single value. The difference, however, when you're using a template node is that in addition to that simple value, that text string that's being displayed in there, I can also add some style elements. So I'm going to add some CSS styling to the time overlay class, which is what I just assigned the class of that div. So what can we do with this time? We could make it, for example, let's center the text in the display. So we'll do text align center, and we'll set the positioning to absolute, and the margins to auto. So that should position the display in the middle of the screen. We'll make it fill the whole width of the screen as well. And we'll bring it down slightly from the top, so we don't want it aligned right at the top of the screen, and we'll make it a nice big font, so a 300 pixel font, for example. And I'm just kind of making this up as I go, but you can basically assign any styling you want. So you could put in colors and styles, things like that. So here we go. I sped that section up a bit. I'll just click done because I don't want to bore you with details of CSS, but this is what I've ended up with here. I've got a nice big full screen timer. It's just worth saying, if you go in Firefox, if you load the inspector tab here, you can move the mouse cursor around and highlight different elements of the screen. It will show you the classes that Node.RED has generated for different elements of the page. So here's my time overlay class that I was just changing the values of. And this is all the way I was editing that style in that template node, was just to identify different elements of the page, work out how to control them, and then apply to different styles to them. So now if I play, you can see I've got a nice big full screen timer that's got a nice font and things like that. In fact, if I press F11, I can make the browser full screen. So that's my basic in-game room timer, which is displayed in its own group, in its own tab on the dashboard. And you can display this on a second monitor attached to the same PC that's running the game, or you could actually display it on a completely different device at all. Anything that can get on the network and can go to that web page could display that. Okay, so now our flow is starting to get a little bit more complicated, and it might be worth us just revisiting and kind of tidying it up and refactoring a little bit. So we've got our time remaining in the dashboard for our games masters, and also one for the players, that are both coming off this loop function here. We also have our setup function at the top, but it might be worth thinking about other events that might want to happen in the game that are triggered on setup and on loop. And for those, we're going to use something called links. So a link, it says it creates virtual wires between flows, and that's exactly what we're going to do. So as a way of tidying this page up, we're going to create a link out, and we're going to put that at the end of the message flow of the setup function. And we're just going to give that a name. So we'll call this link on setup. Let's correct the typo there, on setup. So that has given that link a name, and we can create many links at the end of each of these message flows. So this is the one that happens when we click the play button. So we'll direct this to on game start, we'll call it, and then we'll do another link out at the end of this flow here. And so this is when the stop button is pressed, this flow starts. So we'll call this one on game stop. I can't type. On game. It's what happens when you try and talk and type at the same time. On game stop, we'll call this one, and on gain stop. Oh, goodness me. There we go. And then we'll take a link out to the end of this one as well. So effectively what we can do here is define a whole lot of events, and we'll define them as links out on this tab. And then these links can have corresponding links in on other tabs. I'll start them off. So we don't need those. We don't need those anymore, so we'll get rid of those. We'll move these up here. There we go. That's a bit better. That's a bit neater. Now, let's see what else. We could do a link at the end of our game loop as well. Let's just move these up a little bit. So we've got our game loop up here. So this is now going to be on game loop. So every time we want to have a flow that is triggered every second of the game, so every time the game is looped through a new frame and we want to have any kind of message flow that is triggered by that, we can use a link in node that links to that node there. So for example, let's think of another sort of triggered event that we might want to have. Perhaps we want to have an event that happens at after a certain time has elapsed in the game, for example. So we'll add a link in node this time, and this is going to connect to the link out we had there. So we're going to double click it and select on game loop like that, so you can see the virtual wire has been created, and we're then going to go to this switch statement, and we're going to add a switch which is going to trigger different paths depending on how much time has elapsed in the game. So what value are we going to look at? We're going to look at how much time there is remaining, so message.time remaining, and we're going to say first of all if it is less than, and we're going to put a number value here. So remember, the time remaining is the one that is the unformatted milliseconds number. So we'll put that, we'll send that output to number 1. Alternatively, if it's less than 3, we need a higher value than this. Now this is important. What we're going to do is we're going to check the rules in order. We're going to stop after the first one matches. So we want to check the rule that's going to be furthest away, we want to put first. Because if it's less than 358,000, we know it will also be lower than this. So we're going to check them in order, and we're going to stop after the first one that matches. So you kind of want to put the most constrained output as the first one in your list, or the one that's furthest away. So we'll call this timed event triggers like that. There we go. Okay, so now you see we've got 2 outputs coming off this node, depending on which one of those conditions was matched. So how are we going to use those? So for the next thing, we're going to put a change node there, and we're going to put another change node underneath it, and we're going to connect those to the 2 outputs of our switch node. So if the top node here, if this one was the one that got triggered by the switch node, then we know that the timed event that fired it was the number 2. So it's the second timed event, sorry. If the one at the bottom was activated, then the timed event was number 1. So remember, they're kind of listed in reverse order. The one that happens second is the one we test for first, because then what we do is we stop testing rules as soon as they one that is found that works. Okay, so at the moment, so we've got these 2 rules here. So the one that is furthest in the distance is the one that has the lower number, because this is a number that's counting down. It's a little bit complicated, but you'll kind of get it. Now we only want to trigger these when it changes, so we're going to add another type, which is RBE, the report by exception node. And this is basically going to make sure we don't keep on re-triggering the action. We only want to trigger the first time the timer gets lower than this amount, or the first time that it gets lower by the other threshold amount. We only want to trigger it once. That's what RBE is going to do. It's a report by exception, and this only allows the message to flow if it's changed value. Then we'll put a switch after that. Double click on the switch. So this one, what we need to know is which one of the 2 paths did it come down. Message.timed event, we'll say the number. If it's equal to 1, we'll send it to number 1. And if the message timed event was equal to the number 2, we'll send it to number 2. So this is very similar to the switch we were doing before, but because this is the other side of the RBE node, this will only get fired once for each time the value exceeds those threshold amounts. And then we'll create 2 more links here. So we've now got a link here, and we'll call this timed event when only however many seconds remain in the game, for example. So again, you'd probably want to put a real number there, but I'm just putting that for now. So let's say you wanted to have it when there's only 10 minutes of the game remaining, you wanted to trigger a sound effect, or to change the lights, whatever it was. And this one was when there were 35900 milliseconds remaining. So we'll just leave those linked out there. It doesn't matter that they're not connected to anything, but that flow is now available for any other flows on any other sheets. They could use those nodes to trigger an action at some point in the future if they want to. What other kind of events might we want to create a trigger for? Let's start another flow on this sheet. So we're going to create all of our event triggers we'll put next to each other, basically. We'll connect to the on game loop again, but this time maybe let's create a random trigger, so something that has a random chance of firing with a given probability. So again, here we'll go to a change node, and we'll set a new variable. We'll call it message.probability, and we'll just type in a number. So let's say 50. So we have a 50% chance that each time this flow gets called, something's going to happen. And we know it gets called once a second because it's being called from the link-in node that comes from the game loop. And we'll connect a function node here. And in this function node, let's just put a few extra spaces. So we'll say var rand equals, and we'll create a random number, and we'll round it to a whole integer number as well. So we'll do math.random times 100, and then we'll round that to a whole number. So that line there is going to generate a random number between 0 and 100. And if that random number is less than the probability which we assigned in the change node in the last step, then we're going to continue the flow. So we're going to return the message object, which is basically like saying continue passing the message object down this flow to the next node in turn. So there we go. And then what we're going to do is we'll put a link out at the end, and we'll connect that there. So if that function node was successful, it will pass the message on, and it will come to this link out node. Not even event, random event, let's call that. So this link out node is now available for any other workflows and any tabs to use as the basis for another flow, and it's got a 50% chance of triggering every second. And you can add many more links as you want. So this is our GameFlow tab. Is going to contain all of our event triggers, and it's going to expose them as link out nodes which other steps can use at various points of the game. We'll deploy that to save our changes. So let me show you now how you'd actually go about using one of these event trigger link outs, and we'll use the example of that clock prop which I've got running behind me. So we'll create a new flow, and I'll simply call it clock timer. I mean, how you arrange your flows is totally up to you. The way I typically do it is I have a one flow which is kind of like a global thing related to events, and then one for each prop, but it's totally up to you really, whatever makes the most sense for the layout of your room. And the flow for the clock timer is going to start with a link in node. So this is what's going to allow us to create these virtual links between flows. If we double click to edit that, we can choose which link out we're going to link it to. Now our clock we want to continuously update as the game runs, so we're going to choose on game loop. And you see what that's done is that's created this little sort of indication here that it links to something on game flow. And when we go to game flow and select the loop, we can see that it's going to the clock timer as well as to the two triggers down here. Okay, so this is basically started off a new flow here, and what we're going to want to do is first of all we're going to want to retrieve the current global time remaining. So we'll set global.time remaining. Sorry, we're going to set the message time remaining to the global time remaining. Sorry, I got that the wrong way around. So basically the global time remaining, that's being updated by the node here remaining. And what we're going to do is we're going to grab that and put it into this flow so that we can access it later on. So we're going to set the message time remaining, so the context of this message flow is going to retrieve the global value, and then we're going to pass it to the clock. And this bit is so easy. So you can see that I've got a load of different nodes here for sending different kind of messages to different devices, and this is what I'll be looking at in later videos to see how you can control Arduinos and Raspberry Pis, things like that. But for this example, the clock that I am using was running a web server on a WeMos D1 Mini. That's how I set it up before. And so we're simply going to make an HTTP request to that web server. So we're going to call HTTP 192.168.1.4. That's the URL of the WeMos device on the network. and then we're going to pass a query parameter in, and what we're going to pass in is going to be the time remaining. So this is a message context parameter, time remaining here, which is what we set here based on the global value. So this is a whole flow that is triggered from the link out of the game flow. It retrieves the global message value into this flow so that we can use it subsequently. And then we are making an HTTP request, passing that parameter in, and that's what's going to pass that value to this device, and that's what's going to set the hands. And that literally is it. That is all of the programming required to activate that clock prop. Now, I know that there is a lot of stuff to try to take in this video, and if you've been able to follow along with me, then thank you very much. But there's just one more trick I want to show you, which is going to make this a lot easier in future videos as well. So rather than having to type out every line by hand, what I'm going to do is I'm going to copy and paste the output of my workflows as a JSON file that you can then import directly into your Node-RED instance. And I'm just going to show you quickly how to do that. So if I just expand my window back up again like this, and what you can see here, so if I can select either just a handful of nodes, or I can select an entire tab like that, and then go to this menu up here, and you can see we've got options for import and export. So when you export, you can either choose to export the current flow or all flows or whatever the selected nodes are. And then to import them again, you can simply go to the same menu here and just paste that value into the window here. So if I, for example, wanted to share with you the way that I have created these random event triggers, let's say as an example, I can select those, go here and go to export. I can then copy and paste all this into the clipboard. Copying clipboard. Now if I delete them from my flow here, oh no, I've deleted them, but no worries, they're still in the clipboard. So I can simply go back to import, paste them in, and you can choose whether to import them into the current flow or into a new flow. Click import, and there they are back again. And that's a really, really good way of sharing just sort of snippets of code and things like that. So in my next videos in the series, I'm going to be going through the steps again, just to try to get you familiar with knowing how it's all set up and how I've done it. But I'll also be giving you links to that JSON file so you can import the flows into your own workflows, into your own Node-RED instances, and hopefully use them yourselves. So we've made it to the end. Thank you so much for watching. I think this is amazing software. I think it's really good. It's very powerful, and I'm using it now in pretty much all of my new projects, so hopefully it will be useful to you too. If you've got suggestions of particular things that you'd like to know whether you can do with it, or some example of software services or particular bits of hardware that you'd like to know how to connect to, please let me know in the comments below, and I will try to cover them in future videos. But otherwise, thank you very much for watching, and I look forward to seeing you next time. Okay, cheers, bye.